A very pleasant welcome to everyone. From this video, I am going to showcase my team project on automatic toll collection system for embedded systems development. This project was built to minimize the real-world problems that were faced by many due to the current running system, which was also highlighted in my project pitch. This project was built to work as a user-friendly environmental project, which meant less time utilized and a smoother experience altogether. This system was built using the vehicle's inbuilt GPS system that would help in tracking down its current whereabouts and perform a certain toll transaction on the distance that the user had traveled. Functioning of the GPS was to track down the total distance traveled by the traveler on certain roads and then give a calculated amount to be deducted. Our project's primary microprocessor is Raspberry Pi 4, on which the core of the project resides. Our Raspberry has a very specific purpose, and that was to gather the coordinates of the vehicle that were going to be provided by the GPS module. Once we had accumulated the coordinates, then these would be used to trace down the vehicle's location using the mapping interface that we had built via Google Cloud Console. As these coordinates get marked to the mapping API, then we will get the exact location of the vehicle. But for this mapping interface to work as desired, we need to provide it with the coordinates, which will be done with the help of a real-time communication platform, which is PubNub. This platform will convey the coordinates from the local server to the cloud console. We can say that the server is the location where all the calculations happen regarding the distance traveled by the car and the amount that has to be deducted from the client. Now we are being provided with the distance that the vehicle has traveled and the amount that has to be deducted from the client. This is where our Arduino Nano comes. It gets the accumulated information and provides it to the respected recipient via email with our designed IFTTT protocol. Now let's take a look at how did we perform on the following roadmap. Our project was heavily based on the coordinates that were provided by the GPS module in the form of longitude and latitude. But unfortunately, the GPS module was not functioning how it was supposed to be. To fix this issue, we tried many different GPS modules from many different areas. We even tried to code the documentation of the GPS module, but none of these methods were giving us the exact coordinates. However, we had to test our software, and for this exact purpose, we shifted our coordinate algorithm to manually give the host server its respected coordinates. This worked as expected, and we got the mapping interface to show the distance that the car has traveled and the cost that has to be deducted. Here, the first image shows the code of the IFTTT protocol, whose functioning was to send the emails of the client. The most right image shows us the code for the GPS module where the longitude and latitudes were to be displayed. The image shown on the second slide displays the mapping interface with track distance and cost calculated. On our project showcase, there were some remarks given to our project, on which we gave some thought and came to the conclusion about these suggestions being an upgrade to our project. We have seen in many cases that the GPS system can be bypassed through multiple loopholes that have become a very heavy concern. So to track down the location, we thought of using a SIM track location instead of the GPS module. This is solely because that the SIM locations are more accurate and cannot be bypassed through low means. Many of the drawbacks of the GPS are written here, where a SIM could perform better. For example, the GPS requires a network connection to function. The SIM-based locations are economical, and the users can manually deactivate the GPS to avoid the tolls. So, in all conclusion, the sim location based would bring a raise to our project if we think to change it. This project was achieved by Manav Singh and Tushar Sharma. Thank you.